You get an alert from finance. A customer was charged twice. You open n8n. The workflow is green. No errors. The webhook ran. The Stripe node succeeded. Twice. This time. A user got 10 identical Slack messages because a retry loop kept resetting the same side effect. In both cases, the workflow worked. Operationally, it failed. That gap usually isn't a node problem. It's a memory problem. n8n executes steps. It does not inherently remember what already happened. It does not inherently know what should have happened next. And it does not know inherently how to recover when it fails halfway through. So you add state. The mistake is adding state in the wrong place. If you pick the wrong layer, you don't just fail differently. You create new failure modes that are harder to see until money or trust is already gone. When you're deciding whether to use n8n tables, the question is simple. Are you trying to store business data? Or are you trying to store workflow memory? Workflow memory is what lets you answer 3 operational questions. Did we already do this? What should happen next? And if we fail mid-flight, what do we do now? Tables is strong when the state is there to control execution, not to become your system of record. Here's when tables is the right tool. You need idempotency. You need to prevent duplicate side effects when events replay. You need controlled retries. You want to track attempts, last error, and when to try again. You need correlation. You want it to tie an inbound event to downstream work so you can reconcile outcomes. You need lightweight coordination, throttling, queuing, simple status transitions. You need short-term caching to avoid repeating expensive API calls. You need minimal breadcrumbs so you can debug what happened without guessing. If what you're storing is long-term source of truth, needs complex relationships, or will be heavily managed by humans, tables is usually the wrong layer. Hold that thought. I'll come back to it with clear guardrails. Now, with that decision boundary in mind, let's talk about the problems that step green but broken incidents. The highest ROI pattern is an idempotency key. Every inbound event gets a key that represents the side effect you're about to perform. Not the workflow run, the side effect. For a webhook, it might be event_ID plus the action name, like EVT_123:create_invoice. Before you create the invoice, you look up that key. If it exists and is marked done, you skip the side effect. If it doesn't exist, you create a record and proceed. Now, retries and replays become safe because the side effect is guarded by memory, not hope. The next pattern is retry tracking you can trust. Most retry failures are self-inflicted. Infinite loops, retry storms, or retries that happen too fast and trigger rate limits. In tables, you store one row per item you're trying to process. You keep attempt_count. You keep last_error. You keep next_retry_add. And you keep a status. When a run fails, you don't immediately rerun the whole workflow blindly. You update the row. You schedule the next attempt based on time, not emotion. Then your workflow only picks up items where next_retry_add is in the past and status is retryable. Pause here, because this is where reliability changes. You're moving from the workload retries to the system retries with control. A very common use case is lead intake dedupe. Sources reset, webhooks fired twice, forms get submitted again, people use aliases. If your CRM right is the side effect, you keep a lightweight index and tables. Key it by email, external_ID, or whatever is stable. Store last_same_add. Optionally, store the CRM record ID you created. Now, when the same lead comes in again, you update instead of creating. Or you drop it, but you decide deliberately. Another pattern is webhook correlation and reconciliation. This is how you answer with certainty what happened to this request. When a webhook comes in, you generate or capture a request_ID. You write a row that maps request_ID, the status and result. Queued, processing, done, failed. If you need to respond to the caller, you can return an immediate acknowledgement and process asynchronously. And later, you can look up the request_ID and see the outcome. This is also how you debug without reading run logs like tea leaves. Now, let's talk about throttling, because rate limits are where green workflows quietly degrade. If you have multiple clients or tenants, one noisy client can consume your entire budget of API calls. In tables, you track per client counters or last_run timestamps. Before you call the downstream API, you check whether that client is allowed to proceed. If not, you defer. You don't fail, you don't hammer, you queue. This gives you fairness. And it prevents one integration from destabilizing everything else. Another practical pattern is temporary enrichment caching. If you enrich domains, emails, or company names, you're often paying per call. And you're often calling the same thing repeatedly. So you cache the enrichment result in tables, keyed by the input. You store a timestamp. When a new request comes in, you check the cache. If it's fresh enough for your use case, you reuse it. If not, you refresh it. This reduces costs. It reduces latency. And it reduces timeouts that cascade into retries. Tables also works well for a human-in-the-loop review queue. You don't need to build an app to do basic operational gating. You write items into a queue table with status pending. A human reviews and marks approved or rejected. Your workflow pulls for approved items and processes them. The key is that the handoff is explicit and the state is visible. When things go wrong, you need breadcrumbs. Not full event sourcing, not a data warehouse. Just enough to reconstruct what happened. Write run underscore ID, item underscore ID, step name, timestamp, and outcome. If you have to do infinite response, this cuts your time to root cause dramatically because you can see where it diverged. For multi-step automations, the failure mode is half-finished limbo. Step 3 succeeded, step 4 failed. Then a retry starts from the top and duplicates step 3. So you track state transitions. Queued, processing, done, failed. And you store last underscore step completed. On resume, you don't guess. You continue from the last safe point. This is not about elegance. It's about preventing duplicate side effects and stuck work. One more powder that matters in real operations is backfill and reprocessing control. You will rerun jobs, you will replay history, you will migrate. If you don't track checkpoints, you either overlap and duplicate, or you leave gaps. So you store process ranges, process IDs, or a cursor. When you rerun, you consult the checkpoint and proceed deterministically. Now, as you're listening to these patterns, keep asking one question. Is this workflow memory? Or is this business data? Because that's what decides the storage layer. If you need lightweight memory right next to execution, tables is a good fit. If humans need to view, edit, and manage the records daily as part of operations, Airtable is often the better layer. It's not about durability. It's about the human workflow being the product. If the data is a long-term system of record, or you need complex relationships, constraints, and serious querying, use a real database like Postgres. That's where you want strong guarantees and scalable access patterns. If you force the wrong layer, the failure modes get ugly. Silent duplicates, runs you can't reconcile, and the classic incident question, why did this fire again? So here are the guardrails clearly. Do not use tables as your primary system of record for customer data, accounting data, or core business entities. Do not use it for complex relational modeling or heavy reporting. Do not use it when you need strict database capabilities at scale, like advanced queries, constraints, and long-term durability requirements. Use Airtable when humans need an operational workspace. Use a proper database when it's real backend data. Use tables for when it's great at lightweight state and control that makes n8n workflows reliable. Track what's processed, track what's pending, and track what must not happen twice. If you want help mapping this to your environment, leave a comment with the trigger, the side effect, the failure symptom, and what you're using for storage today. I'll tell you which pattern to apply and which layer is the right place for the state.